And now that for the last method. So what will the equations look like? What will these trig equations look like that will require this method? So what you'll get in these is a mix of trig ratios. So for example, you can see here that you've got a sec squared and a tan. Now, you might notice that as a squared and be thinking initially, oh, could this be like the previous method because it's got a square in it? Not exactly, yet, because we've got different trig ratios. We have to deal with that to start with. Because here in this one, we've got sine squareds, we've got sines, we've got coses, we've got cos squareds. We've got quite a variety. So it's a little bit like some of those difficult functions that you differentiated in the beginning. The key to getting them right was to simplify them. And it's the same here with these trig equations. We're going to do simplifying well before we start solving. It's such a common thing that happens, and sometimes you don't realize that that's what you're doing. But simplifying is a different step to differentiating. Simplifying is a different step to solving. So let's have a look at what we've got. The purpose of simplifying is we might be able to turn it into just a single trig ratio, and then we can use methods 1, 2, or possibly 3 when we've got our equation just in terms of one type of trig ratio. Okay, so some of you would be thinking you know a little about sec squared. Hopefully, you know that it's come up somewhere. I think that if I would just have a read through the whole of the equation first before we jump into deciding on anything. Then we've got a plus tan x, and we've got it equal to 1. Now, often we don't really want our equations equal to 1. Not when they start to get more complicated. If they were very simple with just one trig term here equal to a number, that's great. But just keep this in mind that we often find it easier to solve equations when they're equal to 0. So we may be wanting to bring this across and put our equation equal to 0. So that's just on first read through, just observing what you've got, thinking about what the actual terms are. In going back to sec squared, well, I suppose with sec squared we've got some options about how it can be rewritten, and one option is to put it as 1 over cos. But really, knowing we've got a tan, it may not be the best thing to do, because then we've got a 1 on the other side as well. So have a think about something else we know about sec squared, and hopefully you've done enough questions requiring you to make a substitution for sec squared using this particular identity. You'll go, oh yes, I do know something else about sec squared, and that is it can be replaced with 1 plus tan squared. So that's what we're going to do. So you can see I've written my 1 plus tan squared instead of sec squared, plus tan of x is equal to 1. Now, what are you seeing is happening there? We've got tan squared plus tan squared plus tan, and we've got a 1. However, if I bring this 1 over, that disappears. So I've got tan squared x plus tan x is equal to nothing. Can you see a connection to a previous method? Hopefully you're seeing the connection just back to method 4, because we've got multiple terms of the same trig ratio, and really nicely that this is a squared. So you probably can see if I let u equal tan of x, I'm going to produce a nice quadratic equation to solve. So take u out, becomes u plus 1 is equal to 0. Therefore, u is equal to 0, or u is equal to minus 1. Now, what was u? Tan of x. So I'm thinking about where tan of x is 0, or where tan of x is minus 1. I'm going to add the restricted domain here. X is greater than or equal to 0, less than or equal to 360, just so that I don't have an infinite number of answers. Therefore, x would be 0, for the tan of 0 is 0. And when do we get negative 1 for the tan? We know that the tan of 45 is equal to 1. So, but we know that tan is a negative here and here. So how do we name the angle in the second quadrant? We name the angle by taking 180 minus 45. So that's 135 degrees. And the other quadrant we know that tan is negative in is the fourth quadrant. And in the fourth quadrant we do 360 minus 45, which gives us 350. Just squash that in. So there's actually 3 answers within this domain for the solution to that equation. In this second example, you hopefully you can have a bit of a read through it and realise that there's quite a lot happening. We do have an expression for sine squared in terms of cos squared, but this has got a 2 in front of it, which is really going to complicate things because there's no 2 in front of the sine squared. We've then got the addition or complication of a sine x cos x term. So another little technique for you to be aware of, obviously, is this. Now, it's a technique, and techniques are just as important as rules. So make a note of this, that there may be some sort of trig equations where you need to divide through by a trig ratio. However, as always, if you're going to do that, you must state cos x and cos squared x must never be 0. So we're making that statement that cos x can never be 0 because it wouldn't be possible to divide through, which is going to be a technique we'll use in our solution. Okay, what does that end up looking like? Sine squared on cos squared minus 3 cos x on cos squared, 2 cos squared on cos squared is equal to 0. Sine squared on cos squared will be your tan squared. One of the coses will cancel out, leaving a sine on cos, which is tan, so a minus 3 tan. Cos squared on cos squared is 1, so we've got a plus 2 is equal to 0. Now, same trig ratio, 1 with a power. It's looking like a quadratic, isn't it? So let u be tan of x, and we've got u squared minus 3u plus 2 is equal to 0. I think you can see solving that is a u minus 2 and a u minus 1. Therefore, u is equal to 1 and 2. What was u? Tan of x is equal to 1, and tan of x is equal to 2. you'll have to use your calculator to solve tan x equal to 2. We know that tan of x equal to 1 will give us x is equal to 45 degrees, and the other quadrant where tan is a positive is down here, and we do 180 plus our 45, which gives 225. You then need to go to your calculator and solve x is equal to tan inverse of 2, and then make sure you give the angle down in this fourth quadrant as well. Your calculator will only give you one solution, and that will be the acute angle, and then you will find the angle around down here in the third quadrant. You may have been wondering why I didn't divide by sine squared. How did I know to divide by cos squared? It's a little bit of trial and error. It is absolutely just trial and error. If you divide through by sine squared, something may have come out in that you'd get some cot squareds and you'd get cot. And we do have some properties about cot, but you could have had that u was equal to cot of x, and away you go, solving a quadratic, and come back eventually and write your cot in terms of tan. So it wouldn't be all lost if you divided through by sine squared. But like I said, it is really just all trial and error, and best to try something than not to progress on and be trying to produce an equation in the form that we could have, or we can solve by some of the previous methods.